So yesterday we worked on single function transformations, where we did one thing at a time and we learned what each function transformation did. Today we're going to do multiples at once. It gets a lot easier the more you practice, but you have to practice. So today we're going to start by solving our system. You can go ahead and solve it any way you want. Graphing, substitution, elimination, but you must know how to do all three systems, solving systems, by the summative. So, if I was going to solve the system, I would use substitution. Elimination would be just as good. But because they're both y equals, I'm going to go ahead and use substitution. So, I will have x squared plus 4x plus 3 equals 2x plus 6. So, when we have our x squared, or the quadratic equations, we want to move everything to the same side so it's set equal to 0. Go ahead and subtract 2x, and subtract 6 from both sides. That's going to leave us with x squared plus 2x minus 3 equals 0. Here we have a beautiful quadratic equation, and so we're going to factor this, and it nicely factors to make it even better. And when we factor, we will have x plus 3 and x minus 1. Multiples of negative 3, that adds 2. Here we need to apply the zero product property and set both factors equal to 0. When we solve for x, we get x equals negative 3 and x equals 1. However, these are not our final answers since they're not ordered pairs. So, let's go ahead and find their corresponding y values by plugging it in to our bottom equation. Y equals 2 times negative 3 plus 6. Negative 6 plus 6, y equals 0. And if we plug in 1, y equals 2 times 1 plus 6. 2 plus 6, y equals 8. So, that gives us our points, negative 3, 0, and 1, 8. Last but not least, you should check your answers, and if we check our answers, they both work out to be true. So just like yesterday, we're going to start with parent functions. Remember, parent functions are the most basic form of a possible function. X squared we know is our parabola. Parabolas have points at 1, 1, 0, 0, and 2, 4. They also have a point at negative 1, 1, and negative 2, 4. Ooh, a bad line. But we then connect our dots in a U shape, or connect all our points, and we end up with a parabola. My graphs are going to be a little off, so bear with me. X cubed, our values fall at 0, 0, 1, 1, and 2, 8. It also has points at negative 1, negative 1, and negative 1, negative 8. Connect our dots and we end up with an S-shaped graph. And finally we have our absolute value. Absolute values form a V through 0, 0, 1, 1, 2, 2, negative 1, 1, and negative 2, 2. Pretend that point is at my origin. I'm a little off, bear with me. So, these are our parent functions, and we're going to look at how transformations affect our function. So, to perform multiple transformations on a function, I suggest starting with graphing the parent function. So, I see we have the opposite of x minus 2 cubed. So I know that my parent function is going to be y equals x cubed. And so I'm going to go ahead and graph that in blue, just so I know where my starting point of my graph is going to be. So I have an idea about how I'm going to transform this graph as it moves. So right here, y equals x cubed. Now if we look, we have this minus 2, which will move it to the right. So that minus 2 moves it right too. And then that negative out front is going to reflect it about our x-axis, or flip it over the x-axis. And so if I was going to move my graph, I go from my origin, or my middle, I'm going to go right 2 points, and it would look like this in the purple. However, when I add in this negative reflection about the x-axis, here is going to be my graph. And right there in red is my final answer. One way, if you're uncertain if you graphed correctly, is to just double check a few points. So check to see if the point 3, 0 makes it true. And then what about 4, negative 1? Are those true values? And that's how you can always double check to see if you graphed correctly or not. Our next graph is to graph the value q of x, which is really just another word for y, equals x minus 4 squared plus 7. And so our parent function, which I always like to start with, is going to be y equals x squared. And so I know off the top of my head that my graph is going to be some variation of this blue graph. But let's figure out how it's going to vary. So if we look, we have negative 4. Negative 4 is the opposite of what we think since it's in our parentheses. So we're going to go to the right. We also have this plus 7 tacked on at the end. Because it's tacked on at the end, it's going to go up or down. And it's positive, so we're going to go up. So each point is going to go right 4 and up 7. 1, 3, 1, 2, 3, 4, over 4, and now up 7. 1, 2, 3, 4, 5, 6. So right there is my new vertex. For my vertex, I know I go over 1 and up 1, left 1 and up 1, and that's all you're going to be able to see on this graph. But that's okay, because in the purple is our new function.